Okay, this is the second time I made this because Screencast-O-Matic is like really annoying. But anyway, so I gave you guys that tutorial LinkedIn. Recommend that you use that. So this assignment, this Python assignment, is meant to just give you an introduction to programming. It's meant for you to dip your toe in the water. If you already know quite a bit about programming, or if you already know Python a bit, this video is not for you. So exit out of this video, finish your Python project, turn it in, and you're fine. I'm not assuming that anybody in this class knows anything about programming. So what this is going to do is to show you, I'm going to give you a little bit of tips about how you might want to get started on this, like a recommended path, I guess. You can do this many different ways, as long as you turn in a working Python project at the end. It doesn't matter how you do it, but this is kind of like how I'd probably go about it if I were doing it. There's a few other options, like the links that were given. I didn't write that assignment, by the way. I tweaked it a little bit, but it's mostly written by Caleb Williamson. So I might, who's another instructor here at Pellissippi, I might go about it a little differently than he did. As far as like which links I would recommend, if you can go like write Python program on the web or web page or HTML, whatever, you can go look and there'll be some places where you can write full Python programs in like a input field, right, text area, and compile it there and run it. I'm going to show you how to do it, like by actually installing Python on your machine, sort of. Well, I mean, not sort of, it really is, but how I go about doing that. So first of all, I just Googled Python download, and it took me to the downloads page for Python. If you see this button right here, there's a bunch of different ways you can install Python and different versions you can install. Just if you're using Windows, and again, if you're using Mac, I don't support Mac. You guys are probably used to that for the courses here. If Mac's not a thing that we do typically, so you can probably figure out how to do Mac with Python if you insist on doing it that way. If you don't have a Windows machine, you can do that. But if this is for like the typical Windows user. Most of the students are probably using Windows 10. If you are, download and install this. This is a self-installer, and it comes with an IDE, an integrated development environment. And what that means is it comes with a text editor. Again, most of the programming languages you learn how to do are plain text. They're not word processing documents like Word, or they're not PDFs. They're like Notepad, except you can get a little bit fancier, some stuff that will hold your hand a little bit with the editor. And then you have the integrated development environment, means everything around that text editor. So you type the source code as plain text, and then there's things that will interpret it. In the case of Python, interpret / compiler. It gets a little fuzzy actually, but things where you can do like an input window, where you're a command line, where you're sort of interacting, a console, I guess what you would call it, where you're interacting with it. It'll check your code to make sure the syntax, not make sure, but check to see typical mistakes you might make in your syntax, suggestions, autocomplete. That's an integrated development environment, and there's more to it than that. So I recommend going to Python's site and just installing it on your machine. You probably want it later anyway. More than likely, there's a good chance, there's a fair chance, if you continue doing IT and definitely programming, that you'll need Python again. So it wouldn't be bad to have it on your machine. All right, so download and install this. I already done it, and what I want to say about this too is that there are two. I don't want to get too deep and I was in my video that I stopped before I had my technical problems. I got in the weeds about this, but Python's kind of weird. It has a weird development path. There are two Pythons, kind of. There's Python 3 point whatever, and there's Python 2 point whatever. I recommend doing this one, right, 3.9.2, more than anything, just because this is an easy one to see when you go here. It's on the downloads page. It's kind of highlighted. It's the most recent version. Do this one so we're all on the same page for this assignment. That's my request to you. Do Python 3 point something. If you do 2 point something, if you missed this memo, I can probably adjust to it. But if you're watching this video, at least, please do 3.x is what I'll call it. And what I'm trying to say is that Python has a 2 point something version, and they keep adding versions to the 2 point. Last I checked, now I'm not as very deep into Python, It's not like I'm not a fanboy or something, so I know exactly where they are in their development process. But last I checked, they were trying to integrate 2 into 3, but they haven't quite yet. And there's all kinds of, I'm sure, political, technical reasons why they haven't combined 2 and 3. I don't know if I'm making this clear, but if you imagine how the development of Python has gone, there's a fork where there's a 2 branch and a 3 branch, and they're still building on both of those branches. So that's a fork, right? One, what's it called? Starts with a T. Tine, is it Tine? One of the fork branches is 2 point whatever, and one's 3 point whatever. And there's pros and cons to each. And what I'm asking you is to be on the 3 tine. I want to say it's the word Tine, right? Fork tine. Now I have to go look. Let's look at them. This is talked about this before. Yeah. Tine. So there you go. Anyway, so be on the 3 one. So install that, and if you do, what you should have, and I hesitate to do this. I don't think I can do it. But if you go down to where you search and you type Python, it should have Python 3.9, 64-bit, whatever come up. And there should be something called idle, IDLE in all caps. If you see that, and you see it right now, you want the one that's for 3, because there could be a couple of them actually. Let's see which one this one is. Yeah, see, this is the 2 points, because I've got 2.7 installed on mine from the past. Should just uninstall it probably, so it's out of the way. If I just type idle. If I type idle, say, okay, so if you install this 3.9, it should have idle somewhere in it, because I know I didn't install this. Just go to run idle, the 3.94 version, 3.92, whatever, I don't know, 3 point whatever version. And here's how you would go about it. So what I'm going to first show you is Hello World in Python. So again, this is the way you should approach it. I feel like I recommend approaching it this way, because you get the most hands-on. You don't have like a web site in between you and what Python is. This is actual Python we're using now. The only difference is that we're using this idle IDE. There are other IDEs out there. There's PyCharm. You can just use Notepad to do your stuff. Notepad++, Visual Studio Code. These are all text editors. Sublime. I don't know if people are still using Sublime or not, but that was one. This is a idle. I want to say it's used for other stuff too, but it's definitely used for Python. So you can use this as an environment to develop your Python in. So I recommend going in this path. I think I made that clear so far. So one thing you would do for your project, you probably is go to File, click New File, and you see how it says Untitled. I don't remember how I told you guys what the assignment says for you to save it as, but just for now, I'm going to call it, I don't know. Well, first of all, pick a good place for it to go. So it doesn't have to be like in this default place right here. Put it somewhere where you know where it is. If you have a 1301 directory, like off of your C drive, which I've already worked on this a little bit. Actually, I'm going to call it the same thing. Just save it there. So hello.py, make the file extension py, please. There's other possibilities, but py is like the standard. So use that. I'm going to call this hello.py. Yeah, I'll replace it. So then you can start doing your Python code. So I would recommend, if you're like me and you're a little bit older, configure idle under options and go, it's already on 18. So it's already stuck from where I did it before. Let's make it a little bigger, 20. And you notice there's the interactive console here. Python's an interpreted language, so you could do like little programs like interactively if you want. We're not going to do that here. We're just going to show you how to write a whole program as a text file and execute it. So there's sort of a superstition. I was telling somebody office hours earlier today about every time you learn a new programming language, the first thing you should learn how to do is to print hello world on the screen. It's sort of a superstition. So that's what we're going to do. So in Python 3 point whatever, I think you have to have the parentheses. You don't have to have them in 2 whatever. I don't know, as far as I remember. but you have to have them here. And this is part of it being an IDE. So this is a text editor with inside of idle. And you notice that when I type print and then an open parenthesis, it gives me suggestions about how I might want to finish it. It's giving you the template for the print function. That's what we would say maybe. So it's saying that you print something that's inside parentheses, and there's a bunch of options there that we don't have to worry about right now. So to do hello world, you have to do in quotes, because it's something called a string. A string is just the actual literal in the literal sense of the term literal, literal characters that you want to print to the screen. Is what you would put inside the quotes. So the quotes will not be included. You're just saying, I want you to print whatever's in quotes to the screen. So this is the most simple like Python program you can do. And if you want to see how that works, you run module and always click OK to save. There's probably a way to make it automatically do this. I don't know what it is yet, because again, I don't do Python all the time. But and then you can see it tells you some information about the version, blah, 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 and then it shows you where the output to the screen of running this Python program. Then it has a prompt for you to do more Python stuff. We're not going to do Python stuff. We're just going to use this for output, but we're going to go back to our file and maybe add to it. So I'm going to give you right here, I'm not going to give you a whole tutorial on Python. I'm just going to give you some things maybe to look out for in your tutorials. I want you to go look at the tutorials. You need to do them. And you've got a lot of options. Pick one that seems good. You've got what? It's a week from the day we get back from spring break. So it's 2 weeks. Is it the 24th that it's due? That's 29th. Can't read. It's far away. I think it's a week. So it's 2 weeks from this coming Monday. You got 2 weeks. I didn't want you to work during spring break. If you don't want to, you don't have to. I think you can get this knocked out in the week after we start back if you want to put this off. If you think you're going to struggle with it, I would not put it off. I just knock it out during spring break and maybe take that first week we're back off. However you want to approach it. I just wanted to give you the opportunity to take some time off during spring break if you want. That's why I made it do so much later. But anyway, let me show you how some of the basic things that you want to do after Hello World. So this is how you print something to the screen. This is how variables work. If you're used to other programming languages, you might be used to doing something like this, right? You have to declare the data type first and then whatever. You don't have to do this in Python. Python is sort of, it does have data types, but they're implicitly defined by the value you assign to them. So for instance, if I wanted to do number stuff, I could do something like num. These are horrible variable names, by the way, but num1 gets, say, 2. Num2 gets 3. I say gets, by the way. So what am I doing here? I've declared a variable called num1. I just made this name up out of my butt. There's rules about what you can name things. It can't be something that's already in Python. For instance, print, which we just saw. You can't use print for the name of the variable. I don't really know. I don't think it's important that I know this right now, but gets my cop out. But I don't know the exact rules for naming variables in Python, but I'm going to imagine they're the typical, which is it can be letters of the Roman alphabet, the alphabet we use in English, that version of it without accents and stuff. So maybe it can have accents too. I don't know. But so the alphabet, uppercase and lowercase. Numerals, the Indian numerals, 0, the ones we use every day, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's probably not legal to start with a numeral, but maybe it is in Python, I'm not sure. Underscore is usually acceptable anywhere in the word. If you have a 2-word variable name, for example, day of the week. This is the rule. This obeys the rules of a variable in Python for its name, but it's also a convention. So a convention literally means coming together. Con means together. Vince comes from the word venere in Latin, which means to come. So veni vidi vici, right? Veni, I came, I saw, I conquered. Veni Vidi Vici, if you pronounce it ecclesiastical pronunciation. But so a coming together is what a convention is, and that's what you do at a convention, right? You come together with other people. But when you're talking about conventions in this context, let's see if they show what I was talking about here. Pertaining to a convention, yeah, I know, but whenever to come, yeah, to come together. So it's, and you can see it does actually mean this, an agreement, a treaty, or whatever. These are you can name things in Python according to the rules. Anything that's within the rules works, but you should also use the conventions, which are not rules. You can name things that obey the rules of Python, so the computer will understand it, that at the same time violate the conventions of naming things. So for different languages, people have different conventions. And let me see if I can put this in straightforward English, because I'm making it more complex than it should be. A convention, where you're talking about style in programming or naming variables and that sort of thing in programming, means a sort of agreement, a loose, informal agreement among the people who are doing it about how they want to do it. So for instance, if you have more than one word in Python, I've been told, now there's probably arguments about this, but the convention is to use an underscore between the words. Another convention you would use that still obeys the rules of Python would be, this is called camel case, day of the week. So the first letter is lowercase, that's like the camel's head, and then each subsequent word starts with an uppercase, that's like a hump in the camel, that's camel case. Pascal case is another version, because this is how in the Pascal language it was done. You just capitalize every word. But my understanding is that the convention in Python is underscores between the different words. So here's some examples. And if you just wanted to print out these values, you would say print num1. Let's just see what that does. Print num1. And I also recommend doing this when you're working on your programs. Do things a little bit at a time. Like I had the impulse to show you all the variables at once, num1, num2, and day of the week. And it probably wouldn't have been a big deal in this case because there's so few variables and so few lines executed. But if you're ever working on a program and you're starting to get more and more lines of code, I recommend doing little pieces at a time, running them, make sure they work, and then doing a few more and then run those and see if they work. Do it like a leapfrog kind of thing, a stepping stone kind of thing. So here's what I'm showing. It's a proof of concept here that when I print num1, it actually shows me what's stored in that variable. So num1, I assign 2, use the equal sign. Again, I pronounce this gets. Don't say num1 equals 2. You can if you want. A lot of people do, but I recommend saying num1 gets 2. Because what you're saying is that num1 gets the value here. This is called an integer literal. It's the literal value of 2 as a whole number is being assigned to num1. And now num1 is an integer at this point. I'm assigning the literal value of 3 to num2, and I'm assigning what's called a string. Now, what I'm assigning are these letters of the alphabet, these characters, ASCII characters. Look up ASCII. Here's a comment, by the way. American Symbolic Code for Information Interchange. It's a standard way that things are represented. It's technically speaking, we're really talking about Unicode here, but ASCII's a subset of that, so whatever. So anything that's in here will work in here. So I've got Monday, but I could also make this day of the week 1 + 2 + 3 equals %. Like, so you see the space, $, %. You can see the spaces are also in there. Anything that, can be typed, basically, can go in here. But we want to actually put the day of the week that's Monday. And that's a string. It's denoted by the double quote on each end of it. So this is not part of the string. This is just saying that this right here is a string because I got these things around it. All right, just to show you a little bit more about how this would work then, print num2, we'll add that to it, and then we'll just go ahead and do print num3, day of the week. We're not too far. That's just one more line. Then, we don't have to do one line at a time. You can do a couple lines at a time at least. So We run this, okay to save, and you can see it does 2, 3, and Monday. So that's how you print things to the screen. It's with print. Now, if you want to add to this a little bit of math, for example, you can say print num1 plus num2. Just run this, and what it will do is the order of operations here, and see how it says 5, right? 5, 3 plus 2 is 5. The order of operations here is that it will take this, find out what it is, it's 2, converts it to 2, the number 2. It finds out what this is, what's got 3 in it, it's the actual number 3. Then it does the operation, 2 plus 3 is 5. So what it's really printing is 5, because it's printing the result of this, it's called an expression. An expression is something that evaluates to a single value in your code. So if you take a variable, again, this is a variable. What is a variable? It's called a variable because it can change its value. But I think it's more important to think of it this way. A variable is a named location in memory. It's a named storage place. So think about, if you store your junk somewhere in a, what are they called? Storage units or whatever, where you have to have a key to unlock. So like it's got probably a certain number on it, right? Think of it that way. There's a number on it. In this case, the number is NUM1. And if you open up NUM1 and look inside of it, you have a 2. That's what a variable is in most programming languages. And again, you can change what's in there. You can take the 2 out and put a 3 in, take the 2 out and put a 17 in, take the 2 out and put a negative 17 in. But it's a named location in memory. So every time it's referenced in your code, what you're really referencing is this value, in this case, negative 17. You're not referencing the num1 at all. The num1 is just the key to get the value. Num2 is a 3. So, and it's going to say negative 17 plus 3. What if you add 3 to the negative number? You get what? Negative 14? Let's see. Let's run it and see if my off the top of my head math works as I'm doing a video. There we go. Negative 14. So, and it works for any of the typical operations, arithmetic operations, as you would call them, arithmetic. So you can subtract, and it goes even further into the negative. You can multiply, which negative times a positive is a negative, right? I need to find out how to make that default. So you can see negative 51 down there. The only other one left is divide. This will perform something. I don't know how Python actually does it. Let's see what Python does. It's probably integer division. No, it defaults to floating point. Okay, that's interesting. So that's division. It's a /. If you want to multiply, I already did that. That's the star, but I didn't say star when I did it. There's one more standard thing that you would use here called modulus. I don't expect you guys to know it. It uses the percent sign. It's actually not percentage at all, though. It has nothing to do with percentage. It's an operation called the modulus, and it's the remainder. If you divide the latter thing into the, like if you divide num2, 17 into 3, how many times does it go into that? And then, 3 into 17, how many times does it go into that? Goes into it. Let's see, 3 times 6 is 18. So 3 times 2 is 12, and you'd have more than one left over. Oh, it's negative 17 though, so maybe 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18. I'm not sure how it gets the one left over in that case, but it's the result. It's the remainder result of long division. I have to do it on. I'm not a computer. I have to do it on paper. Okay, so that's that. The arithmetic operations. If you use the plus sign, let's see, day of the week. So if you wanted to print out the plural of this, you could do something like this: print day of the week. Plus S, but you have to make it a string, so S, there we go. This is called concatenation, string concatenation. So when you use the plus sign with strings, which is what these two things are, that's a string, day of the week is a string, and this is a string literal, it's the literal string, one letter literal string of S. It does something called concatenation, which means to tack onto the end of. So it doesn't actually add like math. It does what you would expect. See, it's got Mondays now. If you need spaces, you need to put the literal spaces in somehow. And we don't need spaces in this case because we're just pluralizing, but this is just for the sake of example. You can see how it's Monday space S because I put a literal space in there. All right, so that's a little bit about strings. You've seen some addition. If you wanted to assign, to another variable, answer gets num1. Let's do it actually this way. Just as a real quick example. Sum looks like it's built in because it's got a weird color. That makes me nervous. So I'm going to call it total equals num1 plus num2. It might have worked anyway. It probably would have worked in the context, but I'm going to risk it. Difference equals num1 minus num2. Keep in mind the order matters when you're working with division and subtraction. Product is equal to, or gets, I should say, I told you should say gets, and I'm not doing it either, but it gets the result of multiplying num1 times num2. And then quotient gets the result of taking num1 and dividing num2 into it. So just a review of your arithmetic. And then, by the way, this is a comment. This is stuff that you have in your source code is what it's called, this file, but it doesn't get executed. It's just for you, the programmer, to read, and other programmers who read your code to read. You might use it. I use it for planning a lot. I type out the steps I need to do as comments, and then I fill in the code. Typical thing I would do. I didn't do it here, but so some simple arithmetic, showing you all these. So of course, this is called an operator. It's the addition operator in this context. This is an operand. This is a left operand, right operand. You multiply those. You apply this operation addition to these two operands, and you get the whole operation. The result is a total. Operand, operator, operation. I think I've covered all the words there. Anyway, so just a review. I don't know what you call them with addition or subtraction, but or multiplication really. But this is a dividend. This is a divisor, and this is a quotient. So then if you wanted to see what the results of all those are, you'd have to individually print them. So it figures out what they are and stores them in those variables. Again, those are all storage lockers right here. This has the word total on the outside. This has difference on the outside. This has product on the outside, and this has quotient on the outside. And on the inside, you have the result of adding these two numbers together, subtracting this one from this one, multiplying these two together, and dividing this one into this one is what's inside of each one of these. In quotes, I'm doing air quotes, lockers, storage lockers, buckets, anything you can think of that would contain, it's like a container for something else. It's one way to think of variables. And again, it's Python's very loose about this. To declare a variable, you just write the variable and assign a value to it. You don't have to declare it ahead of time like you do in other languages. For you guys who might have done other languages. All right, so you can see all the results of these. So apparently num1 plus num2 is we know that, negative 14. That's one of the examples we did. And then further into negative, remember me saying that, it's negative 20. Multiply the two together, we did that one. So we've done all these. It's just showing you side by side the result of doing each one of these. But this is not where this is coming from. This is telling you what these operations do, but this is actually the result. Print total, that makes this happen on the screen. Print difference makes this happen on the screen. So this is really how it should line up, but I'm just showing you that these are the answers to these mathematical operations, but the way you see them on the screen is print. Now, as far as what you need to do for your project, I'm going to show you one, maybe two more mechanics maybe that you can like take all these things, combine them, watch the tutorials if this is not enough. I'm just trying to give you guidance about what you should be thinking about. But let's do something like a simple guessing game. So secret number gets, I'm just making this up out of my butt, 13. And then what I'm going to do is show you a couple of new things. So I'm going to say user guess. I've just declared a variable. I'm going to assign this value to it. It's going to be the result of what comes back from this function called input. And I'll talk more about this in a minute. Probably should say enter a whole number, but so what this does, this is called a function. You don't have to learn all about functions yet, but it's good to know how this function works because it's very useful. What this does is it gets input from the user's keyboard. So what you will see when you run, let me just run it right now, actually just make sure it works too, because I had trouble with input before. Just make sure input works the way I think it does in this one. Yeah, I think it does. So far what we've written is just this. We've written secret number gets 13. So somewhere in memory, which we don't see as a human being, but the computer said, okay, I'm going to make this, take this bucket in memory, this square, this storage locker. I'm going to write secret number on the front of it, on the door, and then inside I'm going to put the number 13. Then the next line says, okay, I'm going to make another loser, y'all. Storage locker, and it's going to have user guess on the door, and inside it's going to have whatever the user types after the user reads the message that says enter a number. So input says that part in the parentheses puts the string. Anything you type in here will work. I just decided to put enter a number. It's called a prompt, by the way. If I wanted to do, let me actually do this, show you what I mean by comments. Determine the secret number. Prompt the user for a guess and store the response. The next thing I'll do is check to see if the guess is correct. And the last thing I would do in this very simple program is I would inform the user of guessing correctly or not. All right, so this is 2-in-1 thing here. In other languages, you'll see that you've got like where you prompt with print, for example, and then you do something else to get the end. This is combined in one. It's kind of cool. So input says I'm about to ask the user to type something at the keyboard. I'm going to get what they type and store it in that variable over on the left, which in this case is called user guess. What I'm going to type to the screen is enter a number. So we saw all that happen. Now at this point in the code right here, as long as they didn't do something weird that made the program crash, which is possible probably at this point because we haven't done a lot of error checking, but I'm not asking you to do that because this is a very simple project I just want you to do. The next thing to do is to check to see if the guess is correct. So at this point, what we have is a secret number storage locker with 13 in it, and then we have whatever the user typed on the keyboard should be a number. And I'm calling them storage lockers, but in these variables, just call them variables from now on. In these variables, you have those two numbers. I want to compare them now. So here's another thing you can do. If user guess, and this is why we say gets for the other equal sign, because there's a different equality. Use two equal signs. So if the user guess is equal to the secret number, secret underscore number, colon, then, and you notice how it indented over 4 spaces, that's by default in Python, and there's a lot of questions about this already, but indentations used to indicate blocks. If you're from another programming language, indentations used to do the same thing that curly braces, for example, do in other languages. It groups things together that are dependent on another thing. So for instance, what I've just done is what this is called a condition. The value of this is either true or false. It's called a Boolean, named after Charles Boole. I think I might have talked about that earlier in one of my other videos. The answer to this question you're asking is true or false. The question we are asking is the value stored in this variable the same as the value stored in this variable? That's what this equals means. It means actual equality, not assignment, which is what this is. This means, I said secret number gets 13. You could also, long-winded, you could say the number 13 is assigned to the variable secret number. That's what the equals means there. That's not the same thing. You're not changing anything here. You're just comparing. So you're saying, are they equal? This is the equal sign you have in your math class. This actually isn't. It's inspired by that, because after this statement is done, they are equal. Like the value in here is equal to this value after this is completely done. But before this, in the middle of executing this, secret numbers, who knows what, 13's way we want it to be. So we're saying, take this and shove it into there. That's not the same thing as comparing two things that are already set and you're not changing them. So you'll notice this too, by the way, and this is something I love to talk about on my programming classes. So I may or may not have you guys in programming classes. But if you're ever looking in like a YouTube live chat or general chat, trade chat in World of Warcraft or on some game or some anywhere where people are just like chatting away, sometimes they'll say something like so-and-so equals idiot. And very frequently, more frequently than you would think, you'll see somebody type 2 equal signs instead of just 1. And then you know that person's a programmer. This comes from C. Ultimately, C is the first language I know of that had the 2 equal signs to mean equality. Maybe it inherited that from some previous language. I don't know. But I know BASIC just uses 1 equal sign actually for equality. But anyway, you know that person's a programmer. Call them out. Say, hey, you're a programmer, aren't you? Because you typed equal, equal. And here's why. It's because, especially if you learn C, C's very prone to this. If you type 1 equal sign instead of 2 equal signs when you mean equality, it will create bugs in your program that are really hard to track down, especially when you're a new learner and you don't know why it's happening. And once you've been burned by that, for the rest of your life, whenever you say equals in your head as you're typing, you'll type 2 equal signs. So even though it wasn't programming, like it's just chat, the person says equals in his head, but he types 2 equal signs because he's a programmer. He's been burned by at some point in his life, and that's typical. Almost every programmer who has to do the 2 equal sign somewhere gets burned by it at some point. Or either that or just learns that, always equals is 2 equal signs, that their fingers will automatically type 2 equal signs. So look out for it. I promise you. If you go somewhere where people are chatting online in real time, maybe even comment sections sometimes, if they ever type equals as a shorthand for is, you'll see this. You'll see 2 equal signs. Okay, that's a tangent anyway, over. But what I'm trying to say is there's a difference between these. So what this is doing, what this line's doing is saying, is it true that the thing in here is the same thing as the thing in here? If it is true, then do the thing that's indented here. So I'm going to say print, got to actually use quotation marks, your guess is correct. Yay. All right. So, and this is an example of the type of thing you could like have submitted, but if you don't just do this. If you do like a guessing thing, add a little bit more to it. Don't just do this and turn it in. I want you to be a little bit creative on this. You don't have to be you don't have to write a super program, but don't just turn in what I'm doing right now. But if I hadn't done this tutorial and this is the thing, I would probably give you full credit for this, because I just want you to write like a simple program. You see how it works. Okay, so here's another keyword called else. Else is what happens if this is not true. So if this condition is true, it does this indented part. If you add an else, now you don't have, let me show you. I'm not going to use that else right there. Just do this. Just to show you how this works. All right. And of course, that's what this is supposed to be. So, and you can see I can sort of do both in one, so I'm just do it right there. So let's run this, see what happens. Okay to save. The answer is 13, right? So I'm going to type something like 7. Thanks for playing. So it's not very helpful, but you can see it did exactly what I told it to do. So it didn't print, you got it correct, because I didn't get it correct. The if statement took care of that. So let's run it again. Let's guess the correct answer this time, which is 13, right? And it didn't work. Oh, no, why? User guess is equal to secret number. All right, I'm going to leave that mistake in because it's been a while since I did Python, so I forgot some things here. A little bit of a wrinkle here has to do with something called data types, and it took me, I don't know if you can see the time, but it took me like 30 seconds to figure this out. But the reason is because, remember, and you guys know programming, might know what I'm doing here already, but this 13 is a literal whole number integer that you're assigning to secret number. So now secret number is what's called a data type integer. And the response you get from the user from the keyboard's string. So it's not 13, it's 1 and a 3. It's the ASCII value for that numeral 1 followed by the ASCII value of the numeral 3. It's not actually the mathematical concept called a number, an integer in this case. It's not the value 13. It's kind of like comparing Chris and 13. Chris is a bunch of letters, a bunch of symbols versus the numerical quantity called 13. So what you have to do is convert what the user guesses into an integer using this function called int. This will take whatever this is. If it's a string, it'll try to convert it to an integer, and if it looks like an integer, like if it looks like 1 and a 3, it'll convert it to the actual number 13 and then compares them. So let me show you that. I'm going to leave that mistake in so you can see I make mistakes too, but you can see, maybe get a little bit insight about why this works the way it does. So yes, is correct now. And again, it's because instead of comparing 1 followed by the thing that looks like the numeral 1 followed by the numeral 3, comparing it to, imagine doing your hands, right? Both hands, and then are fully open, so you've got 5 and 5 is 10, and then doing 3 fingers is 13. It's comparing, it's kind of hard to describe. It's the difference between a numeral and a number, and I hate that my dogs are barking right now. I know. I'm just going to talk through it. Somebody's in the cold sack, I'm sure. So it's the difference between like the word for something and the actual value. They're stored differently in the computer. So anyway, so you can see this works. Now, if you wanted to add in a little bit more information, you would probably then send the else in. So the else is going to say, if this thing's not true, then do this indented thing down here. So I want to make it capitalized so you can see it for sure. See how it's different. You got to make sure everything's right in here, right? You keep seeing how I keep forgetting those double quotes at the end. I need to add them back, because if I don't, it won't work. It won't even run correctly. Let me leave it off and show you. So if you're working with this stuff and you have problems, you get stuff like this. This is why you need to find out. The computer's dumb. You have to put things exactly in its language, or it'll get it. It won't understand what you're trying to tell it to do. All right, I accidentally closed. I'm waiting for the dogs to stop barking. Here we go. So I'll add that quote back in and run this again. All right, enter a number. Let's enter 12. Oh, it's not correct. Too bad. So let's run it again. Let's do negative. Let's actually do something like this. Then you might get an error. So don't worry about that. It's just saying that, hey, I can't convert ASK I can't convert that into a number, so it won't work. The problem, the part that's failing is this part right here. It's saying I can't take this, turn it into a number. You see, with base 10, base 10 is what we use every day. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you add more digits, right? So whatever you have to type in there needs to look like a number. You guys can't see me typing actually. So if I run this module, or can you? Yeah, you can see me typing. So type 1 and a 3. Right? If you type gibberish, it has to look like a number. You can type any number, any integer. Right? Negative 12 is not 13. That's correct. Let's run something else. Run module. I'm going to do 2.6. Or 2.4. It's another problem. A floating point number cannot be converted into a whole number and cannot be converted into an integer, so it's going to fail. You guys do not have to handle this. In real programming, there's ways to handle all the possibilities to make sure your program doesn't crash, which is what this does. It's called a runtime error. You guys don't have to do that. You can assume correct input is what is sometimes described as when you're doing these projects. Like assume correct input means that assume your user is not a total idiot and doesn't type in stuff that he shouldn't be typing in. So in other words, don't worry about dumb users. I'm just saying dumb as a shorthand. They're not necessarily dumb, but all right. So that's an example of a simple guessing the number program. You have to rerun it every time. Now, if you wanted to do, I'll show you one more thing. If you want to do a guessing program that keeps going until they guess the right answer, until the person guesses the right answer, then you would need something called a loop. And that's all I'm going to show you. If you want to learn more advanced topics, you can go to the tutorials and learn more about like functions and who knows what else. Lists. I haven't told you about lists. Lists is a big thing in Python in particular. Tuples, I guess. You might want to learn about those too. The built-in functions you can use. I'm not going to teach you about any of that stuff. I'm just going to show you the basic. These are this is a very actually accelerated nutshell of like maybe the first 3 or 4 weeks of programming that you learn in a normal programming class. First you learn about variables and assignment and input and output. Then you would learn about decisions is what they're called, with if statements. And there's other constructs that do the same kind of thing. If, else if, all that stuff. And then you would learn about repetition or iteration or loops, which is what I'm about to show you. So if you want to enhance this a little bit to where the program doesn't end until the person guesses the right number, you could do something like this. I think I want to pause and set this up so you don't have to struggle with watching me make a couple of mistakes. And let's see, what time is it? 7:22. Let's see how long it takes me to get this working. All right, this is 4 minutes later. I tried something I decided you guys didn't want. It's too advanced for, like, you can do it on your own if you want, but incorporating the answer secret number, and you have to convert it to a string. Well, I don't want to get on that. So just tweaked it a little bit. So what we do, determine the secret number. That's a comment. Again, this has no effect on the code. It's just for us to read. So I put 13 in the storage locker. I get a number from the user, and then I have a loop. So what this says is, another way of reading, while is correct. You can say while in English, but I like to say as long as. So I'm saying as long as the user guess is not, this means does not equal, bang equals. So bang is like cartoons. Bugs Bunny shoots the gun and the little frog comes out and it has a flag on it with an exclamation mark. That's why you say bang. It's easier to say than saying exclamation mark every time you see it, or exclamation point, or whatever you want to call it. It's too long. You call it bang in programming. In the programming world, if you hear bang, they're talking about that character. So bang equals means does not equal. Bang itself just means does not. So I'm saying as long as the user guess is not equal to the secret number, and then you have a colon, just like you had I left the colon out with the ifs before, but ifs and loops are very similar. They have a condition. This is a condition that's either true or false. As long as this condition is true, this stuff here, this indented after the colon up here, this happens. If this is ever false, this won't happen. The thing is, it can happen over and over. And if you notice, you see how I have input user guess? See how I have this statement? I have that same statement right here because I want to get another value from the user and check it against the secret number. And every time it's not the secret number, it asks that question again. It tells you that it's not correct, and then it asks you to enter another number, and it changes what this is. This is something people struggle with when they first learn a programming language. Variables. The whole point of the name variable is that it can change. You can reuse it. You can get rid of the 13, or in this case, say the user typed 7 the first time. You can get rid of the 7 and put an 8 in the next time. You can get rid of the 8 the next time and put in a 20. And this keeps repeating until this is false. The moment this is false is when they are the same. If you take the string that the user types in, which is 1, 3, convert it to an integer, which is what this does, and you get 13, and you compare 13 to secret number, which is 13 right now, they are the same. So if you ask the question, is it true that 13 is not equal to 13? That's false, right? So it skips this stuff that's indented and goes down here and prints your guess is correct, and then the program ends. So let's run this and just see it in action. So again, enter a number, That's that right there happening. User guess gets input, enter number. So I want to enter a number. Sometimes that auto stuff's not helpful. Windows. Anyway, let's type in, it said 7 first time, right? My example. So 7. So what happens is it true that 7 converted to an integer is not equal to 13, this integer? Is it true that 7's not equal to 13? That is true. So it will execute what's indented. Print, your guess is not correct. Was not correct. Try again. And then it does this line right here. It says, get a number from the user. So prompt, type that to the screen, enter a number. The user will type a number, and that will go into this variable, the storage locker, the variable called user guess. So if I type 8 now it goes back to the top of the loop, and it says, is 8 equal to, is it true that 8 is not equal to 13? That's true. So it repeats again. Not correct, enter a number. So let's do 13 this time. So I put in 13 goes into user guess, then you go back to the top of the loop. Is it true that 13's not equal to 13? That's false. 13 is equal to 13. So it doesn't do this, it doesn't do this, and it goes to the first thing that's not indented after this, which is print your guess is correct. And then the program ends. That's a short little guessing game thing. If you do something like this, expand on it a bit. Don't turn in just this. You're free to do a guessing kind of program if you want. You're free to do other things. Watch the tutorials and stuff. See if you can come up with something cool. An example's already been turned in. Somebody using lists. You don't have to use lists, actually. You can use lists or not. But giving a string, you look through all the characters in the string to see if they're vowels or not. You count up how many vowels, count up how many consonants, and then report that. Like, say Apple has two vowels and 3 consonants, for example. A and E are consonant. A and E are vowels, and PPL are consonants. So that's 2 or 3, right? For example, and other things. So, but watch the tutorials and just think of the best way to go about this, actually, besides, like, this is me giving you like a hint about how to get started. Use idle, the stuff you download from python.org. You can use the web stuff if you'd rather use that, whatever. As long you would just turn in these files, a file called, in this case, it's called hello.py. You would call it like myassignment.py or whatever the name I tell you to call it. And you can maybe make up one. Do use one word, don't use spaces. I think it will work anyway, but it's always better not to use spaces in file names if you can avoid it. So, but .py, as long as it has code that works in Python, you should be fine. But the way I was going to tell you to tackle this is to think of something you want to do first, like a little game you want to do, and figure out how to do it in Python. And then make that work and turn it in. If it's too ambitious, you can't get it to work exactly like it's in your brain, then do it a little bit less. But just do a little puzzle game, something, and turn that in. This is just for you to get an peek inside of what programming's like, especially for the people who've never done programming. If you've done programming, this video is not for you. You've probably already done. You don't need the program. You don't need this video. This is not for you. If you are, and this is the thing about a lot of these classes, is like we got mixtures of people, skill levels. Some people already know programming pretty well. Some people know a little bit about programming, which is still more than you need to know for this assignment, honestly. Some people know nothing about programming, and that's what this video is for. That's what this assignment's for. And it's supposed to say, hey, it's supposed to give you like, hey, if this is how programming works, whether you do programming or not yourself later on, you have some idea of what's going on with programming. Just very entry level. All right, I hope this is helpful. This is the last thing I'm doing for spring break. You guys are on your own until 22nd. Yeah, the 22nd of March. I'll be back with more material, probably a new checklist or something. Who knows? You've got one that takes you all the way through the next week after that. So your next work's due in week 10, which is basically the first week of April. It's right before the first week of April starts, and then we'll do a few more things before we take the I'm sorry. not midterm, but exam 2 for you guys, because you have 3. That's the 2nd of April, so don't forget. So yeah, so you'll have some stuff due a week after you come back from spring break, and then you'll have an exam. So that week that's coming up, the ninth week. It's really the 10th week. The 9th week is spring break, but I count it out from the number. So we jump to 9, which is 2 weeks. Is 1 week from Monday. I'll call that week 9. I hope this is not confusing. It probably is. But that week that we come back from spring break is when I'll start talking about the exam and what you need to know. You start studying for it, and then we finish out the semester and we'll be done. We'll have at least one more project that's kind of like this web page in Python. We'll have at least one more thing, maybe a couple. We might have a presentation for you guys to do. I'll give you more information about that later on if I do decide to do that. But anyway, if you have any questions about that, and for future semesters, if I use this again, some of this might not apply to you. The Python stuff, obviously, this is how Python works, all that, you can use it for that. But some of these details about what we're doing this semester, if I reuse this and forget that I talked about all these details about spring 2021, it might not apply to you. All right. Have a good spring break.